There are many obstacles that can block the path to a successful software project. When you come across one, it helps to think like a seasoned hiker and follow the trail marked by blue blazes around the problem so that you can get back on course and keep moving forward. Welcome to Blue Blazes Podcast. I'm your host for the journey, Jay Tower, and I'm a partner and principal consultant at Trailhead Technology Partners. In this series, we talk with industry experts who share their best tips for avoiding the pitfalls on the path to successful software projects. My guest on this episode of Blue Blazes is Steve Smith, or Ardalis as he's known online. Steve's an entrepreneur and software developer with a passion for building quality software as efficiently as possible. He's a Microsoft MVP, speaker, author, and published trainer with courses covering DDD, Solid, design patterns, and software architecture. In this episode, Steve and I unpack the modular monolith architecture, an architecture that delivers microservices-style modularity within a single in-process deployment. The conversation covers what constitutes a module, leveraging in-memory messaging for event-driven workflows, and choosing between vertical slice and clean architecture patterns. It's an important conversation and one I hope you enjoy. Well, hello, Steve. Welcome back to the podcast.
Hi, Jay. Good to be back.
Yeah, really great to have you. I was talking to you just before we started recording that you are our first guest on the podcast that has come back a second time. So you must have done a good job last time.
Or something. Yeah. Your listeners are a glutton for punishment, I guess.
Well, I always appreciate your perspective on things, and I'm excited for this topic because I know it's something you've been thinking and talking at conferences about a lot. It's also something that is kind of tangential to something that I've been thinking and talking a lot about, which is how microservices are difficult and fraught, and obviously very popular still right now for the last 5 years or so. But we're going to be talking about kind of an alternative to that architecture that's called a modular monolith. So can you give the elevator pitch? What is that? How is it different than monolith? How is it different than microservices? Jay here. Just a quick break in the conversation to share how Trailhead can help you tackle your toughest business challenges. When you're navigating uncharted technology terrain, Trailhead creates custom software solutions that put you back on the path to success. Ready for the next step? Get started with an expert consultation at trailheadtechnology.com/offer. That's trailheadtechnology.com/offer. Now back to the conversation.
Sure, I will try. So a monolith, even though it tends to have a bad name these days for various reasons, is simply a description of how some software is deployed. So monolith just means you've packaged it all up into a single thing that you're deploying. And it's not a distributed system with a bunch of different applications talking to each other. Mm-hmm. And even that's kind of a misnomer because, most typical web applications, they have a browser component, they have a web server component, they probably have a database. So they are in fact a distributed system. But, for the most part, we think of it as like generally most of the logic is on the web server, and the database is just there for storage and the client is just there to talk to it. So it's still considered typically as a monolith, and maybe it just has a single source repo, et cetera, et cetera. What makes the difference between a monolith and a modular monolith is more of a logical separation. So within a system, as it grows, there's probably a number of different bounded contexts or different areas of responsibility that are involved. And in your traditional monolithic architecture, monolithic application, there isn't a lot of separation between these logical units. They're not modularized in any meaningful way. There might be some horizontal separation. You might have in your code a user interface project and a business logic project and a data access project, but that's not the same as having vertical partitions between the thing that's responsible for managing orders versus the thing that's responsible for shipping products. And so what we often see is teams will look at that and they'll say, well, this is a big ball of mud. It's a bunch of spaghetti code. Everything's coupled together. We want to move to microservices or something in order to get that modularity and that partitioning. And that's not necessary because you could get that same partitioning while still shipping a monolithic application. So it's kind of a long-winded definition, but that's kind of how I think of it.
You have a blog post on this topic, I think, where you refer to them as to modular monoliths as like a Goldilocks, not too hot, not too cold, or to bring the analogy home, not too distributed and complicated, but also not too ball of mud and highly coupled. Is that a good analogy for where it falls on that spectrum?
Yeah, I think it is. I think it's there's a whole bunch of different applications out there, right? And potential applications haven't been written yet. And you want the architecture to fit the application that you're writing, right? And its needs. So if you're building, Facebook or Netflix or something, you're going to have a different architectural need than if you're building an internal line of business application to support, the HR department filling in forms, a few times a week. And so like a monolithic simple web app might totally make sense for that internal HR application, and a super complicated hundreds of microservices architecture, maybe that makes sense for Netflix, right? But there is a whole lot of applications in the middle that are business to business or even business to consumer without millions of users that would benefit from something that doesn't necessarily need all the complexity of a distributed system like a microservices first architecture. But you don't necessarily want this thing that's going to be around for a while. It has a bunch of business complexity and is probably evolving over time to have this tightly coupled big ball of mud thing that 5 or 6 years down the road, you're going to look at that and say, well, why can't we ship features? Why can't we fix bugs? It used to take us a day to fix a bug, and now it takes us a week and a half. And, we haven't been able to ship any real new features in a year because everything is complicated and tangled and messing with each other. And I hear that time and again from clients and from folks at conferences, like that resonates. There's a whole lot of systems out there that are in that position, and I'm trying to suggest that there's a way not to get into that state that doesn't require you to go full microservices and distributed system.
Yeah, because in addition to that complaint, I think you've probably heard this too. I've been hearing clients and people at conferences talking about we went microservices and now it's a big mess. And everything is much slower and more complicated and even brittle sometimes and expensive to host.
Yeah, for sure. All those things. Because in many cases, and I know we both have used this term in our conference talks, they've built a distributed monolith or a distributed ball of mud. And they haven't actually achieved the loose coupling and modularity that they were going for.
Right. So nowadays, it seems like, especially in conferences, I hear the word monolith, and it almost feels like it's loaded at, like you were saying earlier, like it's a swear word.
Right. Yeah.
Would you make the argument then that when somebody feels that way about that word, that what they're really projecting all those negative feelings onto is a ball of mud or a bad designed
for sure
monolith?
Yep. Yeah. In my courses where I teach how to build modular monoliths, I show a diagram, and I didn't invent this diagram. I'm sure I've seen it around on the internet, but it really resonated with me, and that's why I use it to describe this. So it's got two axes, and let's say the horizontal axis, the x-axis, is how many things are we deploying, right? Either one or more than one, right? And so if we're only deploying one, then it's going to be a monolith, and if it's more than one, then it's going to be a distributed system. All right, and then on the vertical y-axis, we can say, well, how modular is this? Is everything, modularized? Is everything totally coupled together in a big ball of mud? Or is it, has distinct logical modules? And so in the lower left, you've got your big ball of mud monolith. And in the upper left would be, you've got modularity, but you're still a monolith. So now that's where your modular monolith is, right? Now, if we go to the lower right quadrant, now we have multiple things, but no modularity. And that's going to be your distributed monolith, your distributed ball of mud, where you built a bunch of microservices because someone said that was the way out of this problem, but you still built them so they all depend on each other, or they all share a common database or any number of other microservice anti-patterns, where you're in this area of pain where you've got all the expense and complexity of microservices and all the problems of having a big ball of mud architecture. And then up in the upper right, you've got, this ideal microservices where you've done microservices, you've done them right, you have a distributed system, and each one is independent and isolated and able to focus on its own thing and not tightly coupled to all the other microservices.
It's a very good way to organize that information. Um, so let's dive into some details here. For someone who wants to implement a modular monolith, what in your mind defines what is one of the modules?
I include the user interface along with all the logic and data access and the
Mhm.
database itself in each module. So
Mhm.
if you've done any reading, done any training or anything on like what should a microservice look like, right? It should be independent. It should completely control its logic. It should be where transaction boundaries end. You don't want distributed transactions between microservices. It should own its own data, including that data schema. So it should be able to change its database schema multiple times per day and not worry that somebody else is getting broken by that. All of those rules of building independent microservices apply 100% to individual modules in a modular monolith. And you can tweak those a little bit if you want for expediency. For instance, maybe you use a single database, but each module has its own schema.
Mhm.
So they are logically partitioned within the database, but you're not having to pay for n different databases to support
Mhm.
n modules. Um, but aside from little trade-offs like that you might make for expediency, you're really trying to make it so that each module is completely independent from the
Mhm.
others. And so when the application starts up, it can just go through and load module A, module B, module C, and in each one gets loaded up into the application, registers itself with any routing or API endpoints or things it needs, registers whatever services or dependencies it might have, etc. Without the host having to know about how to do that necessarily, beyond just
Mhm.
calling some registration method, and more importantly, without any other module having to know about that module being there.
So let's say you do this modular monolith shift, or you write a new greenfield project this way. What strikes me as one of the advantages of it is it puts you in striking distance of going microservices. If, say, one of your modules ends up being kind of its all whole own thing that needs its own team to maintain it and is taking a lot of effort, you could decide to like move that out separate. Is that one of the advantages of going in this direction?
Yeah, for sure. If you think about that quadrant again,
Mm-hmm.
if you start out with the big ball of mud monolith and you think you want to go to microservices, it's much easier to go up and introduce modularity into your monolith first,
Right.
and then move individual modules. And you don't have to move all of them, right? You could just have only one, like you just suggested. Only one module really needs to be or deserves to be its own microservice.
Mm-hmm.
And so you don't even have to have a full microservices architecture. But you pick that one that needs the scalability or needs more independence or whatever it might be, and you could
Mm-hmm.
make that one a microservice versus trying to take the whole system and rewrite it as a whole bunch of microservices from the outset. Now you're
Mm-hmm.
probably in that lower right quadrant where you're in the distributed ball of mud and it's just nothing but pain.
Right. So when you were describing it reminds me of another architecture that is very popular right now, and I wonder if you could compare and contrast them, which is vertical slice architecture. How do you think that those two relate to each other?
I think vertical slice architecture, which is often compared against clean architecture, is more about an individual bounded context.
Mm-hmm.
So within the modular monolith versus microservices discussion, an individual module or an individual microservice, and again, those are more or less the same thing. The only difference being how they communicate, whether it's in memory, in process versus over the network.
Right.
Either one of those could be organized using vertical slice architecture or clean architecture. And it's another benefit of going to modular monoliths or of microservices is that each individual bounded context, each individual module, you can choose which you prefer, which the team prefers, or which makes more sense for this particular module. So again, in my course, it has half a dozen modules involved in the sample app that we build, and some of them are built using clean architecture to show how that would work, and some of them are built using vertical slice architecture, so you can see both of them. And they both live in the same solution side by side, just in different modules.
Makes sense. The way you described it, it sounded like maybe you had a personal preference for vertical slice in your own projects. Is that true?
I honestly generally use clean architecture for most things, mostly
Okay.
because I prefer to have the domain logic be totally separated and some
Mm-hmm.
abstractions that I generally use, like repositories and specifications make it so I have to write very little database code, and it keeps all my domain logic very unit testable.
Yeah.
Most of the folks that I see that are successful with vertical slice architecture generally make the trade-off that they're going to write more integration tests, and that works for them. I'm still happier generally if I can unit test everything, and so that's mostly why I tend to go that route. But at the end of the day, the main difference between the two is when you're creating a folder structure, it's whether your top level folders are things that separate based on UI or infrastructure concerns or domain logic, or your top level folders are the individual features or use cases that the system is using. Yeah. And then, within each one of those use cases, you'll probably, like if you're doing vertical slice architecture, within the, add product to cart feature, you're still going to need to have some data access logic, and maybe you've got UI in there, and you've probably got some business logic. And if you're using something like EF Core, you're probably not going to have a separate DB context in every folder. So you probably still have some folder that's shared that has your data access stuff in it. And so it's not totally vertical slices, right? You still have some different folders for shared logic and shared things like database access. So it's mostly just a matter of which folder structure you prefer.
Makes sense. So let's talk about a couple of things that might be on somebody's mind who's just hearing about this for the first time listening to this, which is you referenced the data stores being somewhat separate, but maybe hosted together. And then the other one is messaging between the different modules. So let's start with the data store. You talked about it's a monolith, so they could potentially be hosted together or separate, but probably together if it's a monolith. How do you see organizing that in a typical modular monolith project?
Another benefit of having modules, which is the same benefit again that you get if you go microservices, is that you can pick the right data store for each module. And so it might be that module A is going to use SQL Server, and module B is going to use a NoSQL database, and module C doesn't need anything more than Redis. And so they each have whatever data store makes the most sense for that module. And so, yes, you could say that, everything is SQL Server. We're just going to use EF Core for everything, or we're going to use Dapper for everything. And we'll put it all on one database, one logical database, and have different schema within that database. That makes it really easy for you to spin that up and deploy it locally, and or host the whole thing in a container or whatever you want. Like all the simplicity that gives you is very nice. But if you want the features of this or that data store for a given module because it needs it, then you can totally do that. And every module can have its own data store and its own data access technology, right? So you want to use Dapper for this module, but another team wants to use EF Core, and somebody else wants to just write, their own SQL code or whatever. That's all fine.
Yeah. So really, it feels like if you think about what you're trying to accomplish with microservices, but you just think about deploying them together and having them communicate, like you said, in memory, in process with each other. You're doing microservices kind of in process with a single deployment.
Exactly. And so you're avoiding the whole 12 fallacies of distributed computer. It's not 12, but whatever the fallacies of distributed computing problem, right? Like, your debugging is way easier when it's all in process. Your performance is way easier. Spinning it up in a local environment and hosting it is way easier.
Yeah.
Right? Trying to get a dozen microservices all running with the correct versions on your local machine to debug a particular use case is not nearly as simple as just hitting F5 in your IDE and seeing the whole thing run and then step through it. So, just the developer experience is leaps and bounds better generally when you have everything in process.
For sure. Way easier to manage when you're talking about like cloud costs or development environment experience. All of those things get better
for sure.
Monolith.
Yeah. In fact, one of my courses is like on Dome Train is on like, hey, we went on microservices. How do we get back to a modular monolith? Because a lot of teams are feeling buyer's remorse and some regret at where they got to. And so it's a low code course that basically just talks to you about all the planning and everything you need to do to move from microservices back to a modular monolith if you found out that you weren't happy where you ended up.
I want to ask you more about that because I think that'll be a really valuable resource to the listener. But I want to ask first about messaging between these different modules in a modular monolith. Typically, is that going to be synchronous or asynchronous?
Uh, Both. I think it depends on what you're doing. So
Mm-hmm.
if you're firing off a command and you're hoping at some point that that happens, and you don't need a response, you can just assume it was successful. Then you can just fire off a message for that potentially, or in many cases it's not even a command; it's just an event. So like, well, when the customer registers, we want to send them an email telling them they successfully registered. Well, that doesn't have to all happen in one method. It could be that module A is the user registration module, and some other module, let's say module B, is the notifications module, and module A fires off an event that says user created, and module B picks up that event and fires off an email that says, hey, welcome. And that type of asynchronous event logic is common. It's common in modular monoliths. It's common even more so in microservices. The difference is that in microservices, you have to have RabbitMQ or Azure Service Bus or some other cloud-hosted thing that's
Mm-hmm.
complex and costly. Whereas in your monolith, you can just use something like Mediator, or Mass Transit has an in-memory provider, or Wolverine has something similar. And so there's various mechanisms you can use to support that type of in-memory messaging.
Now, if you're doing anything that is more of a write type of an operation, a command, and you're doing it asynchronously, it's possible with separate data stores and asynchronous messaging that you start to get into one of the trade-offs with microservices, which is eventual consistency. Is that
For
something
sure.
someone should keep in mind in this
It
architecture?
is. Yeah, it is. Again, I mentioned early on that with microservices, you want to make sure that transactional isolation is per service. And that is yet another thing that is applicable to your monolith as well. So your transaction isolation should be per module. And so if you need two things to always happen with ACID compliance as a transaction, then you should put them in the same module. Otherwise, you should be okay with eventual
Hmm.
consistency. And there's various patterns that you can use, and I show some of these in my course as well, where maybe you use an outbox pattern in module A, and it ensures that eventually that message will get picked up and satisfied by module B.
Mm-hmm.
But it got stored in an outbox transactionally in module A's data store, and that's why we know that eventually it's going to get done, because it's not going to get lost. It's not going to get removed until we see that module B confirms that it got that message and processed it correctly.
So I think this is a good point to maybe give a concrete example of maybe a user story. I know you often talk about like a bookstore type of a example. I wonder if you could do one that I often talk about, which is when I talk at conferences about microservices, I often talk about microservices that are related to like a hotel's operations.
Okay.
Maybe because everyone's staying at a hotel at these events. But you might have a module that's like an administrative module. You set up new rooms when you build the hotel, or that type of thing. Take rooms out of commission or something like that. You might have a maintenance one that kind of tracks the maintenance that's happening in different rooms when
Yeah.
things break. You might have a housekeeping one to make sure that things get cleaned. You probably have a reservation taking
Mm-hmm.
microservice. So if you take all of those, what could be microservices, and say instead that those are all modules that are inside of a modular monolith, um, could you walk through an example of, let's say, the hotel opens a new wing and they bring 10 new rooms online through the administrative console, and all the messaging and data store interactions and things that happen between all these different modules that might care about that?
Sure. So in your example, let's just limit it to the administration and, let's say, housekeeping to
Okay.
keep it simple.
Yeah.
Everything else will be the same. Um, so administration creates a new room, right? Let's say they're doing it one by one by one, right? They're going to do 10. So when they create a new room, there's an event that's fired off that says new room created. And
Mm-hmm.
that is sent off as a message to any handler that is looking for that message, that's in this monolith, right? It doesn't have to go out on an external service bus. It's not external at all to the system. It's just in memory. So when that fires off, there's a handler in the housekeeping module that is listening for new room created. And the reason why that handler exists is because housekeeping needs to know that there is this room that now it has to track the status of. Who's assigned to clean it? What's the status of it? Has it been cleaned today? Et cetera, et cetera. And often what you'll use is what's called a materialized view, which means that module B will have a copy of all or a subset of the data that is owned by module A. And
Mm-hmm.
so in module B, which in this case is housekeeping, it will probably have its own representation of a room. Now, it maybe doesn't have all the details of room that the administrative one has. It
Mm-hmm.
doesn't necessarily know, like, what it costs per night, or I don't know, a million other things that we would track about a room in a hotel. It really just cares about the room number and some other details, like being able to assign somebody to go work on it, right? And so when this new room created event comes in, it's going to insert a new record in whatever its data store might be that says, hey, room 501 has just been created, and now
Mm-hmm.
I've got a record of it in my system.
Mm-hmm.
Now, it may also then fire off some other things to say we need to assign somebody, or more likely, the next time somebody looks at their screen, they're going to see, hey, nobody cleaned room 501 today. But now it's in the system in that module, and people can do that. Now, if somebody accidentally typed the wrong thing and they meant to type in 501 and they typed in 50L, and now it needs corrected, the
Mm-hmm.
housekeeping module is not the place to make that change. It does not own that data. And so the administrative module would have to make that update, and now a room changed event would fire, and the housekeeping module would see that room change thing, and it would update its name accordingly. But it's one directional, right? It's just subscribing to changes to that model, and it's keeping its own copy of just the parts of that model that it cares about. So that's the sort of async messaging that would happen. Now, it might be that there's some additional data that's in the administrative portion that the housekeeping module needs from time to time. I don't know what that might be, but let's say when we assign someone to clean this room, we need to know if the folks that were staying in it had children, right? Because maybe we need special cleanup if there were kids involved. We know how that goes because we're parents. And so, knowing about who last reserved that room, that's not a responsibility of the housekeeping module. So it might have to go make an external to it call to some other module. Let's say it's still in the administrative module, although probably it would be in the reservations module or something like that. There would be an interface that would be exposed as a contract from that module, just a regular, C# interface. And we would dependency inject that interface for like iRoom details service or something like that, or whatever, like previous reservation service. And we would call that and say, get me previous reservation details. And when we call that, it would actually execute code in the other module, and it would fetch the details and say whether or not, it had so many people and if they were kids, and give that back to the housekeeping module. So then it could perform its logic on there. So that would be a synchronous call from one module to another, just using C# code. No microservices, no messaging, nothing async about it. It's just a standard call. And because it's just a standard call, when you're debugging that, you can just step right through it, and you can totally debug it easily and see exactly how it's all working. And it's going to be as fast as any other C# call you're making. So it's nanoseconds between calls as opposed to milliseconds over the wire.
And so just like with microservices, those interfaces and those events become kind of your points of integration and become the more difficult part of the app to change. So you want those to be fairly stable. But because it's all a monolith, it's still possible to change it without much fear, because you're going to get a compilation error or something if you've not implemented all of the calls to a particular interface the same way, right?
Right, exactly. Yeah, you get strong typing, you get compile time checking. I use a separate folder for those integration types that you're exposing. So interfaces that other modules are expected to call, DTOs or message types or commands that other modules are expected to use as part of those interfaces. All those things go into a common folder or even a common project per module, to make them easy to find. And so you kind of know that these things that are in this project or in this folder are public to other modules, which means I should not change them without being careful. And maybe I even need to version them. Although usually with a modular monolith, you don't have to worry too much about that, because unlike in a microservice, you're not going to have to worry about having messages in flight that might be sitting in a queue somewhere. Like, when you change the message format, you need to support the previous message formats as well.
Yeah. And then I guess also similar to microservices, you talked about data being in multiple places, or you could argue denormalized a little bit. This is something that if your DBA is used to traditional monoliths, you might have to kind of convince them a little bit that this is an okay architecture.
Yeah, right. And we've been having to convince DBAs of things for decades now, to try and write better software. So there was a time when everything had to be in a stored procedure, and thankfully for most of us, that time is in the past.
Yeah, that made it hard to update things, version things.
Right.
Okay. Yeah, that was a great example walkthrough. I think that gave a really clear picture of how these pieces would interact. Somebody who's been listening to this and now wants to learn more, see more examples, maybe see actual code on screen. I know you've got some courses online for this. You want to give everybody a chance to figure out how to find those?
Sure. So I've been doing courses for a long time. I've got a bunch of courses on Pluralsight. My modular monolith stuff is all on Dome Train, which is Nick Chapsis's training company. And if you use my online name Ardalis, Ardalis, you'll get 20% off any course. There's often other deals you can get as well. So usually you can find a way to not have to pay exactly full price. But there's 3 courses there. There's a getting started. There's a deep dive. Both of those are built on the same demo application, which is an online bookstore, similar to one that you may be familiar with. And the third one is like I mentioned, it's if you've already gone microservices and you'd like a way back, it's about porting from microservices back to a modular monolith. I also have a bunch of stuff on my GitHub. So if you do github.com/Ardalis, again, Ardalis, look for River Books, which is a modular monolith demo. It's actually the sample I use in the course. And we also have a templating tool called Monolith, like modular monolith. It's all one word, Modulith. And you can use that to just say .NET new Monolith, and it will create a solution for you that's already broken out into modules. And It has a couple of other commands you can use to like add another module. Because trust me, it can be a little tedious trying to create all the projects and folder structure that you need to do this properly. So having a template can really help get you going faster.
Totally. Templates are a great help. Yeah, thanks for sharing those resources. I'm sure people will be interested in checking that out. Well, we've been talking about modular monoliths as an alternative to monolith, fall mud type monoliths and microservices. What other topics do you think would be valuable to our listeners or guests to talk to about things that can help make software projects more predictably successful?
I have a couple ideas, folks I don't think you've talked to yet. So one of them would be if you're looking to have a conversation about the perils of trying to invent your own technology for something complex like distributed messaging, let's say, folks that are in that space, like folks from Particular Software or Jeremy Miller or Mass Transit, any of those folks that build those products would be great guests to talk about that, because I know we see a lot of the time companies have a bespoke message processing or distributed message architecture implementation that one developer decided to build because they didn't want to go get permission to buy a license for some product that would do it better. And so now they're maintaining this thing for years and years and years, just because some dev made that decision, probably without a whole lot of oversight, saying, hey, do we really want to build and support this? So that might be an interesting conversation to have. I know I've been talking to some of those guys about those topics myself privately, and I know there's some things they want to share on that front. And then the other one would be open source in general, right? Like, when does it make sense to leverage an open source package, and what are some of the trade-offs? Like, what happens if that open source thing that's always been free, suddenly someone decides they want to charge something for it? How does that impact your project? That might be another conversation to have with someone.
That's really great. That's happening right now as we're recording this, and has happened many times kind of famously in our industry. So it's an important thing to be thinking about as more and more software libraries are open source. So great suggestion, Steve. Thanks for that. And one more time, if people want to learn more about this on your Dome Train course, how do they do that?
Oh, just go to dometrain.com, do a search for modular, and all my courses will come right up. And then again, if you use Ardalis, 20% off.
Awesome. Steve, this has been really valuable as usual. So thanks again for your time and your expertise. Really appreciate having you on.
Yeah, anytime.
That's the end of this Blue Blazes podcast. If you're interested in hearing more conversations like this one, with industry experts focused on how to make software projects more predictably successful, make sure to subscribe. Trailhead can be found online at trailheadtechnology.com, on Twitter, LinkedIn, and Facebook. Until next time, thanks for listening.